Hello, this time I would like to take a look at three quotient rule derivatives. Quotient rule is when you are having a function that has a function on the top divided by a function on the bottom, as exampled in this problem. Now, of course, the rule for a quotient, called the quotient rule, can be drawn as this. If I'm trying to find the derivative of f of x divided by g of x, it is the derivative of the top function times the bottom function minus the first function, or the top function, times the derivative of the bottom. And that's all divided by the bottom function squared. Okay, so that is our quotient rule. And this first one is not too hard. We're going to try and get through it pretty quickly. So if I find f prime of x of this, I'm going to take the derivative of the top function, which is just 2, using the power rule there, times the bottom function minus the top function times the derivative of the bottom is just 1. And that's all divided by x minus 3 squared. Now this one, because I'm dealing with polynomials, it's got a good amount of simplification I can do. A lot of the time when you do quotient rule, you can leave it just like this. I mean, I took the derivative. I did it. So that is the derivative. You don't necessarily have to simplify. But in this one, I do want to, just kind of as your pride as a good mathematician, you know that this is nice polynomials, and you know that you're going to have like terms that combine. Now I'm putting this right side in another parentheses just to remember to distribute the negative. Now as you go through simplifying, if you choose to do that, 9 out of 10 times, you should leave the denominator as the thing squared. Don't ever FOIL it or multiply it out, because the majority of the time it's not going to help any. You're just going to add work to yourself. So here I have 2x minus 2x, that's 0. Negative 6 minus 1 is negative 7 over x minus 3 squared. And see, that's why I simplified, because I was hoping some nice good things like that would happen. And they did. That was great. So there we did the quick quotient rule with an easy polynomial on the top, easy polynomial on the bottom. Let's try another one. Okay, now the top function is a square root. It's going to make things a little bit messier, but it won't be so bad. Now the first thing I'm going to do is rewrite this in exponent form. So x to the 1/2 divided by 3x minus 5. That helps us because we're taking derivative, we're doing power rules. So when I have the exponent as a number, it's easy to do the power rule. So now f prime of x is equal to derivative of the top function. So I bring down the 1/2 and I have x to the negative 1/2. That would be because I'm going 1/2 minus 1. 1/2 minus 1, which is 2 over 2, and that gives me negative 1/2. So that's my new exponent. Times the bottom function minus the top function times the derivative of the bottom, which is just 3. And then all of that is divided by the bottom function squared. Okay, now again, we did take the derivative, so technically I could leave it there. But I just kind of want to work with it, clean it up a little bit. So in this case, I can distribute the 1/2, negative 1/2 into each of these. And what does that look like? Now for the first one, I have 1/2 times 3, so we'll say we have 3 halves. Then I have x to the negative 1/2 times x. So you add the exponents, giving me x to the 1/2. And then I distribute 1/2 times 5 is 5 halves, and then x to the negative 1/2 goes along with it. Moving over, we have minus 3 times x to the 1/2. And it is still all over 3x minus 5 squared. Okay, can I do any more here? Why, yes, I can. I have x to the 1/2 here, x to the 1/2 here. Those are like terms, so we can subtract them. And I have 3 halves minus 3, which we need common denominators, so I write that as 6 over 2, giving me negative 3 halves. So when I combine those two highlighted like terms, I have negative 3 halves, x to the 1/2, minus 5 over 2x to the 1/2, I brought my x down low because it has the negative exponent. And then it's 3x minus 5 squared on the denominator. Okay, can I clean this any more? Well, I can a little bit. Notice how each of these is divided by 2. So I can factor out that 1/2, and in fact, I'm going to factor out a negative 1/2, leaving me 3 times x to the 1/2 plus 5 divided by x to the 1/2, all divided by our 3x minus 5 squared. Now, why it was nice to factor out that 1/2 is because I can rewrite it as the 1 up top and bring the 2 down low. Okay, if I'm multiplying the top by 1/2, I can rewrite it in this way. So I have 3 times the square root of x, I'm going to switch back to that notation, plus 5 divided by the square root of x, divided by 2 times 3x minus 5 squared, and then don't forget about our negative, so it's a negative out front there. Okay, and there is our derivative, pretty nicely simplified. But again, if you happen to take the derivative and you leave it in this messy looking form, well, technically that's correct, that's the derivative. But it looks just a little bit cleaner if we can work it over to here. Okay, we're going to try one more problem. And you'll notice that this one, it's just the reverse of the other one, the reciprocal. I flipped it. And I want to do this one just to bring up a point. Not every time you see a quotient like this, should you necessarily jump straight to the quotient rule. If I have only one term down low, and it's a power function, like x to the 1/2 as it is here, in fact, I'll rewrite it that way, 3x minus 5 divided by x to the 1/2. If you have just one thing in the denominator, split it up. Because that 1/2, that x to the 1/2 divides both things. So split it up, because then this allows us to use 2 power rules, which is a little bit easier than using a quotient rule. So I can simplify this left one because it's x to the first power. So I go 1 minus 1/2, giving me 3 times x to the 1/2, minus 5 times x to the negative 1/2. Rewrite it like that. That'll make our power rules easier. So in the first one, I go 3 times 1/2, which is 3/2, and then it's x to the negative 1/2, because I go 1/2 minus 1, minus 5 over 2, which actually what I did here, I have negative 5 times negative 1/2, because I bring that exponent down, which actually gives me a positive 5/2, so this sign switches between them. And then I have x to the negative 3/2, and that is because I have negative 1/2 in the exponent, and I subtract 1, which is subtracting 2 over 2. That gives me negative 3/2. Okay, and then let's just clean this up a little bit. That x can go down low, so I have 2 times x to the 1/2 plus 5 over 2x to the 3/2. And if we're really feeling it, we can convert back to radical form. So I have 3 divided by 2 times the square root of x plus 5 divided by 2 times the square root of x cubed. That's the 3/2 power. And there's our derivative. That is a little bit easier than going through the quotient rule with it, and I even took some extra steps to simplify it, which added a bit of time. But again, if I have just one thing in the denominator, one power function, split it up and just use the power rule. It's easier, less chance for a mistake.